Hello and welcome to Tech Time Live. My name is Jonathan Ott and I'm proud to be the Digital Marketing Specialist for BEA. With me today is Rob Rivera, Technical Service Specialist at BEA. Today's topic will be power supplies. Power supplies convert electric current from a source to the appropriate voltage, current, and frequency to power a load. BEA offers both mounted and plug-in power supply solutions to meet the needs of most applications. Topics covered include primary differences and applications, power requirements, transformers, and where and how to use. Let's take it over to Rob and get things started.
Hello, my name is Rob Rivera with BEA Tech Support, and today we're going to be talking about power supplies. We have an array of different power supplies, and they're designed for different things and different applications. We're going to go through each one and hopefully clarify so anybody who needs a power supply will know which power supply will be best for their application. Okay, so getting into our first power supplies, we have Electronics AL175 ULs. Our part number is PS1224. This essentially is the same exact power supply. What is the difference and why would you carry one opposed to the other? So let's open them up and I'll show you. So the D, the PS1224D, this larger box that is designed for batteries, for a battery backup system and enclosure, comes with a red and a black that is actually designed for your batteries and your battery terminals marked BAT, B-A-T, positive and negative. So obviously this is a trickle charge from batteries. So if in case of a failure, you could get battery backup with this system. And this would be primarily used for security. You can use it for other things, absolutely. If you had a sensor on a gate, you wanted to make sure that sensor functioned, as long as you had a wire run from that gate into an inside protected area, because this enclosure is not NEMA rated for outdoor use, so it kind of limits it. This is why it's designed for access control. So primarily, we would be talking about mag locks, electric strikes, locking devices, and battery backup. So if you did have a power outage, you would still have access to that building. And the access would come via the battery backup system. You would rate the batteries in amp hours for the duration of time that you feel you need if you have power irregularities, power outages. So this one again comes with the keys, battery backup, and enclosure that'll fit those batteries all in one nice clean compartment. Also has the knockouts. You'd have use knockouts, low voltage wire runs, 120 volt single phase power coming into it. One of the attributes of this power supply is also in security devices for fail-safe devices, NFPA 72 and NFPA 70 and NFPA 80 all will call for a fire systems tie. Fire alarm controls and fire systems are NFPA 72, but you can't lock people in other words. So you have to have a way out, and fire is king. So if you have a fire system, I have a fire panel over here that I test devices on, the red panel, tied into a power supply. Fire system goes off because there's a fire. It will, via the fire tie, which is designated here as the trigger 1 and trigger 2, and it will power down the system for you. So that's one of the beautiful attributes to this. Also, you have an auxiliary output, aux negative and aux plus. This provides constant power for controls, devices that you want to make and break with relays or access control systems via the access system. But if you had a standalone system, it does come with a strike and lock and common. This is switching power supply that, again, using the trigger, you could activate the system to put out power or stop putting out power, making and breaking. And so that's some of the great attributes about AL175 as our part number 1224D with the larger box. Now, getting on to the same power supply, if you had a smaller application where you did not require battery backup, you could utilize the smaller box. Much more convenient to install, much smaller, same exact power supply, same functionality. You actually still have the battery terminal. So if you did want to do battery backup and you had a bank, a UPS, uninterrupted power supply that is designed for backing up a system, you could still do that on this system. You would just have to run your wires out to that power supply. So same exact power supply, smaller enclosure, no room for batteries. Great for putting in ceilings, above doors, in electrical closets, where you might have a backup system for your high voltage. You have a backup generator for a hospital or such. This would be ideal. Now, these, as I mentioned, are not not NEMA rated containers. So you have to put them in electrical closets and ceilings. That's their design. You can use them on all different types of devices. They'll work on our LZR sensors that are NEMA 4 rated for gates and doors and all types of industrial applications. However, the power supply itself must be in an area that is contained and safe for this enclosure. If that makes sense. We'll move on to the next power supply. So what we have next is a newer addition to our power supplies. This has really come across a need. This is a wall wart or plug-in. There's two areas that we normally use this power supply. Give you kind of a very close up and some of the attributes of this. So this is a wall wart or plug-in power supply. Has a positive and negative. It's 24 volts at 2 amps and it has a security screw on it. So when you have an outlet, you can pull the screw off the center point, put this in the lower, and you could screw this in, and now you can't pull it out. It's screwed in and secured via this screw. This is what has been generally used on standalone access control systems, keypads, small electric strikes, stuff like that. And it's excellent for that use. You can have an outlet near a desk, underneath a desk, and you have a reception desk button, something like that, with the strike or lock, and this works ideal. Also, another place that we use this is for gate systems. When you go out to the gate systems, oftentimes it's a code that you have a serviceable outlet in order to work on a gate or some type of appliance. You have an outlet there. So that outlet, you can plug the 6-way in. It's very common. Any of you guys that work on gates, you'll see a lot of 6-ways plugged in there, and you can use this on the 6-way, and you can isolate power for the H100, i30, for a wide scan, for devices like that. It's a great little power supply for a very nominal fee, really helps you keep your costs down, gives you great clean power. This is a filter regulated power supply, by the way. So excellent little power supply. Very simple, nothing to it. Plug it in, unplug it, you can secure it, as I mentioned. So moving on to our Altronics little power supply. This is the VR5T, my apologies. So this VR5T has four terminals on it, 2 for input, 2 for output. This would be used with like a class 2 power supply, like a transformer. So if you had an existing transformer in a door header primarily, you could regulate the voltage if you had, things that are microprocessed, would require DC power. This is an excellent way to filter and regulate the power. Your 2 inputs would be listed on here, would be our reds, my apologies, blacks for primary, the reds for the 120. So your blacks would go on your inputs here, and then your outputs would be your positive and negative. Now, this is got a little bit of a unique aspect to it. The VR5T is some variable inputs. They're listed in the user guide. And the input on this particular one, you can see, I'm going to show you real quick, that there are an array of VRT products. The VR1, VR1T, 2, VR5B, so on. So this one be the VR5T, and so you can input 24 volts, 50 volt amp or higher, or 24 volt DC, and you'll get out a regulated 12 volt DC out of this. So the design on this system is for a 12 volts, and you could put in 24 volts from an AC transformer, generally speaking, or even a DC power supply. If you had a DC 24 volt output that was not filtered and regulated, you can get it there with this. Very convenient, very small. You can see it fits in the palm of my hand. Designed for an auto door header, can easily be put in small little nicks and crannies. Usually we use sticky backs on these and put them into door headers, and you can see how conveniently it'll fit in very small areas. And again, wiring is very simple, low voltage, very safe, does not require 120 volt single phase power run to the power supply. So that's kind of nice for states that have very stringent restrictions on running high voltage power circuits. So it's very simple to use. So next up is the Meanwell MDR 2024. Now this is probably my favorite power supply for some various reasons. One of them is it's essentially a lot like a transformer. You can put, you have your hot incoming power, you have an earth ground, a neutral, and a load. So it's a single phase input, any single phase circuit. Interesting part about the single phase input is you can have anywhere from 85 volts to 264 volts AC input, and this will regulate it out to 24 volts DC filtered regulated. So that's a great attribute. It also can take 120 volts to 360 volts DC and regulate it down to 24 volts DC. So extremely variable, very flexible. It's a great little power supply. Also very thin, as you can see, very thin, very small, fits in all door headers. Also designed for closets. You can see here that you have a DIN rail mount right here. So if you have a DIN rail, those of you who know what DIN rails are, you can mount this in closets, very common in electrical closets, to DIN rails. And you also have a remove tab right here. So it's designed to where if you were looking at it face on, you could get underneath it back here. You just stick a screwdriver in here and pull it down, you can see, with a little screwdriver. And now it would come off because that is a catch when it's down, and then you can simply put it back up. Okay, so very easy to mount. You can also use this with Velcro, in small headers, obviously a thin profile. There's almost no door headers that this won't fit into. That's why I've liked it, because it's so flexible. It does have a voltage adjustment. So if you have critical microprocess systems, or you have mag locks that are UL listed, they have a power fluctuation of a plus or minus of 10% usually. You can adjust it and tone it right into where it needs to be. DC power out, here's your voltage out here on the top, and there's not too much more to it than that. It's a very small, very filtered, regulated, quality 1 amp output at 24 volts power supply. One of my favorites. So again, very good for small areas. That this does need to be into a contained area where it is not in an area that is exposed to weather elements. So you'd have to put it in enclosure. Should be noted. Now, one of our other power supplies is specifically designed, actually. We actually call this the MicroScan power supply. One of the reasons for that is that this power supply actually has a MicroScan plug-in head that comes with it. So right out of it, here's your output, and this plugs right in the MicroScan power supply. Why we call it the MicroScan power supply. It has another side to it. Obviously, this is the 120 side. Some of our earlier units on this used to come with a plug, but in almost all cases, nobody plugged it in. So this is kind of like a computer type style power supply. We no longer have the plug on the end, so you don't have to cut it off. It's designed for 120 single phase. So you would terminate this on the power from your auto operator in almost all cases. Here's your incoming power. Now, if you have some of our other devices, maybe you have an H100 or you have a flat scan, you can simply cut this top off and utilize the wires and wire it with wire nuts or beanies or whatever your company likes to use. It's a very simple power supply. This is 15 volts DC filtered regulated, and it's 750 milliamps. So this is really designed specifically for the MicroScan or flat scans. It can be used on other devices. It's nice and small. You can easily cut the wires down to fit in your header. Great power supply. The last thing we're kind of going to talk about before we move on to applications is our transformers. Now we do offer 12 and 24 volt AC transformers. This one is a 40 volt amp transformer. So a 40 volt amp transformer using, the formula for volt amps would be 1.66 amps, essentially. So it's just under 2 amps. Great little transformer, AC. You have older devices, Falcons, those type of things. These are great as long as you put it inside an enclosure. This is an iron core transformer, so you'll feel a little bit of weight to it. It's very reliable power. Transformers, and in this manner, are very dependent on the incoming power for what the output is. So if you have 110 volt old single phase 110 line, then your power may fluctuate on the output because the input voltage is different. You go up to 120 volts, all of a sudden you'll see more voltage, and thus more amperage out of this. So that lacks regulation. But for AC devices that are designed for that system, you have to watch that. You have to meter when you put something like this in, because this is dependent on the voltage in your building. So ultimately what it comes down to. So, but very small, very cost effective, and tried and true. And if you have something like the VR5T, my apologies, you can use a transformer like this with that to get your filtered regulated power if need be. So now, talking about some of the applications, you can see here I've mounted and I've been using for my test purposes. You can see that I'm using the PS 1224 standard. You can see that it comes with some holes, which I'll actually show you for mounting. These holes are slip holes, so on the top you can put 2 screws. What we usually do is put a magnetic level. So now stuck to it, and we balance it on our wall. Puts a couple circles on all 4 of the holes. Comes with some screws here. We just put anchors or screws, whatever type of material you're going into, and it's that easy to mount. It's a very practical system. You can see here you have a graph on it. You'll have the same graph on the larger body. Now, a couple things that you need to pay attention to. This one has a little bit of weight to it. So the weight is a little bit confined because it's a smaller area. If you are going to mount this larger box, which also again has a little bit larger of a label, one thing you need to pay attention to is you need to get the rated anchors going in the material that you're using on sheetrock, because once you use a box like this, you're generally using it to put batteries in it. And as you know, the weight of batteries is significant. So you can't just simply put a few little screws in it and stick those batteries in. It's going to pull out of the wall and fall out. So make sure when you are installing something like this, that you get the lead anchor or some anchor that is rated for, say, 50 pounds per screw, and you go into the material that you're going to, whether it's masonry or sheetrock. Pay attention to those type of things. But you can see much bigger space, same exact board, same exact transformer, AC transformer. And essentially the layout is very similar to what I was telling you with our transformer and a VR5T, except for you have the battery backup, which is great for any system you want to endure a power outage. So that's something you want to always consider, is not only the weight of the device that you're installing, but the weight of some things that you might be putting into the device. Now, we talked about this before, but I want to kind of cover this a little bit just to give you kind of an insight on this application. I know it's overly simple, but I want to make sure that everybody understands what it is, why it is, and how it works. Use a standard faceplate on an outlet. This could be commercial or residential. Again, this thing is very flexible. So when you put this into the outlet, you'll now utilize the screw that comes with it to secure it. So now, one of the great things that I like about this power supply is it does give you a red LED indicating that it has power. It's a great little ad. And now you can't pull this out. So as simple as that is, it's actually very important when you're using, it's like particularly security devices with electric strikes and mag locks and keypads. People tend to come up and say, I'm gonna put in my my coffee pot or whatever and unplug your security system, and now you can't access your door. Not only can you do that, nice flat face here that you can put a label on it that says security system. Maybe you don't want to do that. Sometimes you don't want to let people know it's a security system, but nonetheless, very simple way to secure a power supply. Nice option that it has, and it provides very clean, regulated power. All right, so now we want to move into some of the power supplies that are really designed for automatic doors. They can be used a million different places. I've used them on gates and enclosures, NEMA rated enclosures. Again, they're outside, so electrical closets where you do have a wire run out to the gate or the barrier, in lock boxes where you have an access control for a gate system, maybe a mag lock is an access control standalone on a gate, and you'll have a NEMA rated box. So you'll be able to put these type of devices in there. You also have to have 120 volt power in general. And also in the auto door headers for the MicroScan power supply and the transformers. So now I'm going to kind of get up to the auto door header and show you how they fit, where they fit, what you do to make them work. Okay, so the first one I'm going to show you is the MDR 2024. What I've done is I just cut a little bit of Velcro. I use the super duper Velcro that's very difficult to even get off. I put both sides on like so, peel it off. This is the stick side. On the record, you have a little 120 inlet right here that I use as a bracket. And you can stick it right there and then fold it over. You can see it really sticks. And now this thing is in there. It's a great little way to put it in. You can see to get it off, you gotta both hands to get it off because it really, really binds well. And it's a very simple way to make it stick right in there. Now, on the record, particularly, you have inputs for your 120 volt, and you got two spares in case you had a pair. If you have a single or a power supply like such, transformer, so on, you can simply pull off of the 120 coming right here, 2 wires, put it into your neutral and your load. The green is your grounding lug right here. You put another ground on it, run it here, and now you're grounded, you're safe. You got a great power supply, and then you took your low voltage out. Right now I'm powering it off of various things. You can see I've got a lot going on in my test operator, but you can easily pull your low voltage here. And this operator comes out to here. So to give you kind of an idea, the cover would protrude out a little bit beyond this point. So it well fits inside of there. It's a great little power supply. So now, in working with the MICROSCAN power supply, you can see I have some test templates here for the flat scans. Don't want to fall, that'd be bad. Generally speaking, I cut a lot of this off. NEC, NFPA 70, Article 90. You want to be neat and workmanlike wiring, so it's nice and clean. That being said, I got some cutters here. So I want to put it in. I'm going to put my 120 in here in my operator again. I'll again secure it to a location like this, a bracket. Put this over. I could actually even put it sideways if I wanted to. Maybe that's what I'll do because of the configuration. So cutting it down. Cut it down a little bit. Strip it off. So I got my 120 input. Don't want it to be too long. Here's my input wires. Now, of course, I mentioned before that if you had a MICROSCAN, you could just simply leave it like this and plug it into it. It's nice and neat and it'll work fantastic. If you have some other device, flat scan or even another microprocessor unit, BR3, something you just need power for, and you have this power supply, you can just simply cut and make it shorter. Shorten it up a little bit. Rip off chunk. Here's my red and black. Very easy, very quick. Now, with this type of power supply, I generally like to use wire straps. So if you wanted to put them down, the problem is the header cover fits over here and here, so that might not be ideal. But what you could do is wire strap it in here, like so. Straps are bulletproof. You have a bracket, which is great. You could also use tie pads, something I commonly use, but nothing's going to beat this because this is in extremely good with one strap. And now I have my 120 coming out here. I can easily clean this up. Have my 120 coming right there. Get another tie strap. I'm going to drop that in there so it doesn't flap around and ground out. But you can see, very simple, very reliable, fast install, can be installed properly, cleanly, and instead of having a mess on your hands, you have the right power supply for the right application. And I don't have any tie pads on me, or I would show off my skills with making it nice and neat. You can see it'll fit right inside there. And then we have our low voltage output on the other side. We can simply string underneath and go to whatever devices we need. And we can even slip that into the tie strap if necessary. But that's a very quick, easy way of and clean, safe way of installing a power supply for the MICROSCAN. Okay, last but not least, because I'm going to show you real quick how to accommodated transformer. It's something many of you have done many times. Our transformers, I should know, come with some writing on the top. I'm going to tell you something about that. The 115 volt is the red. So this is the 115 incoming high voltage. The output OP, output 24 volts black. I apologize if you can't read that. But if you ever come across a transformer that does not have this label on it, one of two things: call BEA tech support and we'll clarify it for you. Or if you are confused and you reverse the power, like let's say you put the 120 on the black, it's going to reverse the output to here. So you want to, before you hook this up to a device, do not hook this up to a device. If you landed this on power and you measure your voltage, you go, whoa, that's way too much power. Because actually stepping up the power. So, really the best thing to do is to call BEA tech support if you do not have this label. So let me see here. Okay, so back to our transformer. I took my little screw off. It's very tight, so I have to kind of screw it in, which is not bad because I like my transformer to be set in properly and not have a lot of play to it. So back onto our transformer. I've got my screw set in. I removed my bracket. I can simply screw into my backing screw that comes designed with my operator. Some of you might be lucky enough to have something like this. Some of you may not. If that's the case, you could simply use tech screws to go through your header. I know most of you probably have done that before, a time or two. But you can see, makes for a nice, clean, safe install. Whatever you do, don't set your transformer in and just lay it there. Don't just let it lay. You can see our wires. I can actually slip that and move it over a little bit if I need to. Get a little bit more length. So now my wires will go in just fine into my input power. And then we have my low voltage output. So now I've got a nice transformer set in here. If you did need the VRT to clean up the power, you can see right here, I put a little Velcro on it. You might need a tad bit more Velcro. Put it on to the other side of it. Snip it on like so. Nice, neat little backer. And now we simply put our VRT right inside the header. So you can see how this can fit nice and neat. Our inputs now, output power, go into our input power, and then our outputs would go right here onto any of our low voltage devices. But you can see how this can fit into a nice, neat little header, a door header, and be very convenient. So this has been our presentation on our power supplies. Don't know how well I've covered the fact that filtered regulated DC power supplies are all that sit on this table. Everything that I've shown you is filtered regulated except our AC transformer, which I explained is for older units and usually use that as a power supply used with something like a VR5T. So now you can understand the applications, battery backup systems, security systems, all of these pretty much are going to be interchangeable, but the locations that they're designed to be installed in is critical. Electrical closets, plugins, ports, in-gate systems, and so on. Wired directly into auto door headers, pulling off of transformers, and of course, kind of a transformer-esque MDR 2024 power supply, which is very clean, quality power. Hope that makes sense to everybody. We welcome questions, recommendations. Please feel free to communicate with BEA Technical via our phone number, our email. We welcome correspondence. We're here to help you with any questions you have on power supplies or our devices. Thank you for your time and have a great day.
Thank you everyone for watching this Tech Time Live. Today we covered power supplies. We covered primary differences in applications, power requirements, transformers, and where and how to use. For more Tech Time Live videos, visit our YouTube channel at youtube.com/BEAsensors. Also be sure to visit our website at www.beasensors.com. Thank you for watching and have a great day.